So the first thing I'm going to be covering here is understanding location of cut geometry in two-axis operation and what this exactly means and how it works. So in this particular example here, I have a solid model, a prismatic part, and the stock has already been defined. I'm going to display the stock visibility in here. You can see that the part and the stock are already aligned, and you will see that the stock, there's some material thickness that needs to be faced off from the top face of the stock block. So when we go into a typical operation, which would be like a facing in this example, we will focus on our location of cut geometry here. So I'll just make a selection for a tool. And as we go into the cut levels tab, you will find location of cut geometry. So in a facing operation, a location of cut geometry refers to location where your part region for the stock is located, so you can face it down. So in this particular case, if I pick at top and I pick generate without any region selected, the system will automatically take the silhouette of the stock geometry into account to determine the part region. So when no control geometry is selected and you leave it as at top for location of cut geometry and pick generate, you'll notice that no region selected. Do you want to use the stock silhouette? I pick yes to generate. You will see that it uses the silhouette of the stock and automatically it adds one cut level right where the top face of the part is located. So when leaving it as at top, it automatically adds one cut level where the top face of the part is located. So from the top face of the stock down to the top face of the part. Now, if I would like to pick a region for the facing operation, so I'm going to clear this checkbox which says include stock model silhouette, and I'll go pick curve regions. So what I'm picking here is the top face of the part and not the top face of the stock. So if I pick generate, I'm still going to get one pass. However, if a depth is specified, since the location of cut geometry here is set to at top, you'd end up cutting deeper into your part. So for location of cut geometry for a facing operation, what we are selecting is the part region is the face where the stock needs to be. So in this particular case, you don't want to cut below the finished face of the part. So you would want to pick at bottom. And if you want to cut this in multiple steps, you can specify a total cut depth. So location of cut geometry would be at bottom as we are picking the finished face of the part. So we don't want to cut below the finished face of the part. So if you're selecting a curve region or a bunch of face edges to represent your control geometry for a facing, you would be picking at bottom. And as you generate the toolpath, you will notice that the toolpath goes to the finished face of the part. Now we'll be talking about the cut depth controls later during the webinar, but I wanted to emphasize the difference between at top versus at bottom. Now you could also be selecting using pick top. We'll go with that with an example as well. So when you set at bottom, the cut levels would not cut below the bottom face or below the Z location of where the part regions are selected. So if I give it a depth of, for example, 200 thousandths, you will notice that the final cut level will be right where the part region is located as we've selected the cut levels as at bottom. Now, had I selected at top and generated the same toolpath, you will notice that it's going to cut further in to your part region or part geometry. So for this particular example, on a facing operation, the region what you're selecting is looking at where the stock region is located. So we want to make sure we don't cut below that. So we pick at bottom. Now, one of the ways you could also do is you can draw a sketch or a curve that represents where your stock is located. So I'm going to go into my top view, create a rectangle that represents the extents of my sketch. And now if I go to facing, rather than picking the curve region, which is at the top face of the finished part, I can pick a curve region that is located at the top face of my stock region. When I select this, it makes sense to pick the cut level location of cut geometry to be at top, meaning the region is at the top face of your stock and you want to cut down to the desired depth, which could be an 1/8 inch or a 1/4 inch or whatever the depth is, the thickness of the stock you would like to remove from the top face of the stock. So the next thing we'll take a look at is how we can establish cut levels in some of the other operation types. So I'm going to cover for a pocket operation. So we'll go into 2-axis and pocketing. We'll pick part regions. I'm going to use select curve edge regions, and I'll pick the curve that's on this top edge of this stepped pocket. So I pick the curve on the top edge of the pocket. Under cut levels, now the location of cut geometry, since I've selected the part region at the top face or the top edge of the pocket, I would select at top and specify the depth. Now, had I picked the location of geometry at the floor of the pocket, then I would pick at bottom. So in this particular case, it is at the top. I would specify a depth for it and then generate. So the Z levels are determined from the top of the pocket to the specified depth. And you can also take a look at what's called a Z level display, which is available in all operations that have Z levels, to see the Z value that's computed, which is what you would see in your posted code as well, based on where you establish your origin, you pick your location of cut geometry, and specified your depth. Now I'm going to switch to an example where you will see if there isn't a part region that can be selected either at the top or at the bottom, how do we specify location of cut geometry? So in this particular example here, you will notice that we have a chamfer on the top edge of the pocket, and we have a fillet on the floor of the pocket. So when we go into a pocketing operation, I would like to go ahead and select a curve region or the part region right where the fillet, right where the chamfer ends. So I'm going to use select curve edge region. I'll pick the chain around the edge of the part. And now since this region I've chosen is neither at the top of the pocket nor at the bottom, I wouldn't be able to select at top or at bottom, or selecting at top or at bottom wouldn't give me the correct depth. So I'm going to use pick top and specify where I want the region to be or where I want the cuts to begin. So internally, the system automatically moves the Z elevation of the part region to the specified pick top. So in this case, I'm going to use pick top, and I can pick a point or snap to an end point or a near point on the model. And you can see that the pick top represents 0, since 0 being the top face of the part geometry in here. So I've specified the top. So automatically the part region is transformed or translated in the Z axis to the top face of the part. And then you can specify your depth and the other parameters in here. You can pick the depth to specify how deep you want to cut. So I could say I only want to go from the top edge down to the location where the fillet begins. So that's only 230 thousandths. Generate. So pick top allows you to choose where you want to move the region to without having to physically move the part region in the CAD. And you can control the depth once you establish your location of cut geometry. Now, while we are on this topic, I would also like to point out a location of cut geometry for for programming features like chamfers and fillets. Now, if you have a chamfer that's already built in or modeled into your part, you can go to 2-axis and chamfer operation. And for the region, what you would pick is where the chamfer ends. So I'm going to use select chain in Rhino to pick the chain of these edges. So if a chamfer is modeled in your CAD design, you would pick the bottom edge where the chamfer ends, and then under your cutting parameters, you would pick geometry at bottom. If there wasn't a chamfer modeled into your design, then you would pick at top. So going back to the previous example here, if I needed a chamfer on this particular top edge of the pocket, since there isn't a chamfer model in the design here, when I go into 2-axis and chamfer operation, I would be picking the top edge, and under cut parameters, you would pick geometry at top, and then you can specify either the height of the chamfer or the width of the chamfer, depending on how deep the chamfer needs to be cut. So if a chamfer is modeled in the part, then pick at bottom and make sure to pick the chamfer at the bottom edge of the chamfer and choose geometry at bottom. If there's no chamfer modeled, or if you're working off a 2D drawing, then you would pick at top. The same goes with 2-axis filleting operation as well. This also applies for 2-axis profiling operations. So you could pick the geometry at top or at bottom. So in this case, I would like to create a profiling operation. And if I pick the part region where the chamfer ends, I'm going to use select chain to pick a chain of these edges around the part. And since the geometry what I've selected is neither at the top nor at the bottom, under cut levels, I would pick location of geometry to be pick top. And I can use the pick option to snap to a point or an edge on the part, and then specify my depth for cutting. And then I can specify generate to create the toolpath. Now, you could have selected the bottom edge around the part in this particular example. So selecting bottom and specifying the location of cut geometry to be at bottom will ensure that the cuts will not go below the bottom level where you selected. So if you have a need to be able to go slightly below the bottom of the part by a few thousandths to relieve the material, you would want to make sure that you use the option as pick top under cut levels. You specify the start location, and then when you're in your depth, you want to make sure you specify your total depth, plus you can add the amount that you want to go past it. So for example, I could say I want to go past 50 thousandths. So when I do this, it's going to start at the top and go to the depth that you put in. In this particular case, we are going past the bottom of the part by 50 thousandths, and you can see that the Z-level display shows the final depth. So the part here in the example shown is 1/2 inch thick, and we specified to go below the bottom of the part by adding in an additional 50 thousandths. So selecting for at pick top for location of cut geometry will allow you to basically let you cut below or deeper than the thickness of the part to relieve material. Now, if you had selected at bottom, then you wouldn't be able to cut below this region unless you actually move the geometry physically in the CAD. So the location of cut geometry gives you the ability to adjust the Z start location of your cutting without having to physically move the geometry around in your CAD system.